Good day, everybody, and welcome to Ask an Astronomer Anything. I am starting this new series because, one, I love astronomy. Two, I'm really kind of enjoying answering questions in a way that everybody can understand. And three, there is a simple means to ask me and I can respond. So what I'm doing is I'm picking a message off of Quora, Quora, every day, or at least every weekday. I'm going to do this. I'm going to take weekends off. But I'm going to answer a question off Quora and do a quick video chat to kind of explain the answer. And I'm also going to type the same answers out onto Quora, but a little bit shortened, longer, etc., with better explanations, maybe some click links. But any which way. So today's question, and I'm going to start as my first one, is if we had every rocket ever made tied to the Earth, and they were all headed in the same direction, could we pull the Earth through space? Every rocket ever made tied to the Earth. So let's assume we had the ability to get every single rocket ever made, launched, and successfully working out into space. And we had some form of tether that could actually hold those rockets to the Earth without breaking. Nothing like that exists, but let's just say we did have something. Some nanofiber carbon cable that, of sci-fi, unbelievable future sci-fi strength that could actually hold that much force and not break. And not break the rockets themselves. The answer would still be no. Because rockets work... So, yeah, I need a prop. I don't have any props. I need a ball. Alright. Coffee mug. And I'm going to use this TARDIS to represent the Earth. Just pretend it's a sphere, okay? So, if we have a rocket tied to the Earth, the rocket is facing out that way. So, the nozzle of the rocket is then propulsing this way. So that means... So let's go to Newton's laws. For every action, there is an equal and opposite reaction. So the thrust from this rocket is going to propel this way. The rocket is going to go that way. The thrust is going to push back on the Earth this way, even though the rocket is pulling this way. Effectively, there's going to be a zero-sum game. And the Earth is so massive. I mean, so massive in comparison to these rockets, it wouldn't even budge. Honestly, what would most likely happen is if they were all anchored to the same spot on the Earth, a chunk of Earth would maybe rip out because there would be a delay between when that concussive force from the propulsion from the rockets hit the atmosphere and pushed back against the Earth, but the actual force going through the cable would rip out a chunk of the Earth. That would be it. A small chunk, depending on how big the anchors are, but that would just rip off and the rock would actually separate. That would be your most likely scenario. I am not a fancy animator, so I don't have fancy graphics for that, but it's kind of a fun thought experiment, and I would say post this question to somebody like, hey, let's run with it. And they do really cool physics models of stuff like this, and they might actually show what it would be like if you mounted a whole bunch of anchors to the Earth with an unbreakable tether, which, again, doesn't exist. Because if you tried to... let me take the space shuttle, for example. If you had the space shuttle with those clamps that hold down the space shuttle and the solid rocket boosters, when those solid rocket boosters ignite, those clamps couldn't hold it. It would rip those clamps right out of the ground. I mean, we're talking The space shuttle had like 3.3 million pounds of thrust at takeoff. There's no mechanism to hold that much force. I mean, 3.3 million pounds of thrust. Even if you anchored a building into the ground, it's going to rip the building off. There's no... Right now, we have no material that could do that. If we had a... So let's say we made the anchoring bolt in the ground out of the same material as that unbreakable cable from our rocket to the Earth. That cable would basically be pulled out of the ground. Even if you spider-webbed it and mesh it, it would get pulled out of the ground or pull the ground with it, or really it would go nowhere. The actual effect, you may be able to nudge the Earth a few meters in its orbit, but really the actual effect is going to be negligible and calculable, yes, but actual impact, you're just going to tear up some Earth and waste a lot of fuel. It's the thing is, people don't realize just how massive Earth is and how much force it would take to move an object of the Earth's size. I mean, we're talking trillions and trillions of tons of mass, and a few millions of pounds of thrust is not going to do anything. So the long and short of it is, no, we could not. Not with our current technology. You would need planet-sized mass or planet-sized thrust to move the Earth. And you wouldn't want to use thrust to move the Earth. You would want to use gravity to slowly pull it out. You would need another massive object, say, farther away, that slowly pulls the Earth. I'm going to put... let's see if I can go down to my cluttered desk. So let's put the Earth here in this corner, or let's put the sun here, the Earth here, and let's say we pull a massive object here. It will slowly pull, that we start pulling out, it will slowly pull the Earth in its orbit slightly farther and farther. But we're talking something that has so much mass that it can move a planet. Even the moon is actually moving away from the Earth because the interaction of the moon and the tides is slowing the moon and the Earth. The moon is slowing down and going away from Earth because it's pulling just a little bit of energy off of the Earth, and the tides are slowing the Earth down. That interaction between the Earth, the moon, and the tides slows the moon, and it's slowly spiraling out. But eventually it'll get to a point where the tides and the moon kind of even out, and the moon will be in a very stable orbit and always have, it already has the same side facing us, but it'll be a very stable circular orbit, and the tides will be almost non-existent. We'll probably be swallowed up by the sun before then, so, kind of irrelevant. And off topic. But we're talking, the reality is every rocket ever made and every rocket currently made and every rocket made in the next 20 years is not going to be enough to shift our planet in any meaningful, significant amount in any direction. That's it. And that's having to do with mass. And if you want, I can go into some more technical details in conversations. But let me know what you think, and let me know if you have a question in the future. Thank you, and if you like this, let me know what you want to hear about, and feel free to subscribe. Have a great day.